Hi everyone, this is coming to you from Education for All. We are still on exact values of trigonometrical ratios. What we are going to look at this time is we are going to look at a problem actually, but before attempts in solving the problem, I want us to look at quadrants here. When you divide the circle, the unit circle, you divide it into 4 equal portions. We have here, we call this C, this side is A, S, T. That is the cosine, the sine, and the tangent. This is all of the trigonometric function. This side here is called your first quadrant. This is your second quadrant. This is your third quadrant, and this is your fourth quadrant. That is when you divide the circle into 4 equal portions. So what that is telling us is that in the unit circle, all the trigonometric functions are positive here. All of them. All means all 6 of them. The sine, cosine, tangent, cosecant, secant, cotangent, they are all positive here. On this second quadrant, it's only the sine and the cosecant are positive here. The rest are negative. Here is only the tangent and its reciprocal, which is the cotangent, are only positive in the third quadrant. The rest are negative. Here, similarly, the cosine is positive here, and the secant, yes, the rest are negative here. So let's look at one problem from the text exercise, and then we'll see how we apply this one. When you just know how to visualize this way, you can easily solve these trigonometric problems that we're about to start looking at. CAST, cast. This is first, second, third, fourth. Everything is positive here. Here is only the sine and the reciprocal of the sine. So there's a question here that says that express sine 135 sine of sine of 135 degrees. You're asked to express it as a trigonometric ratio of either 30 degrees, 45 degrees, or 60 degrees, trigonometric ratio, and hence find its exact value. We have to express this as a trigonometric ratio. What we have done, sin 30 cos 30 tan 30 is either 30, 45, or 60, and we express it in that format. Those fractions we are having earlier on. So now we have sine 135 degrees. This is well over 90 degrees. So that tells us it's not in the first quadrant. First quadrant is 90 degrees. It's not there. Where do we find sine? We find sine in the second quadrant. Sine is here in the second quadrant. And sine has to be positive here in the second quadrant. The sine is positive and the cosecant are positive here. Those two identity, those two functions, trig functions, are positive here. So sine 135 must come all the way to here. So from here, this is our 0, mind you. So this is sine 135 degrees. This is 135 degrees. Yeah. So what is left now here? Mind you, this is 180. Here is straight line is 180. So this is 135. So 180 minus 135. This will give us 0 here. That remains 7. No. 10 minus 5 is 5. That remains 7. 7 minus 3 is 4. So we have 45 degrees. So there is 45 degrees left here. So since we have 45 degrees, we are now saying that the sine of 135 degrees is the same as the sine of 45 degrees. They're all positive. Second quadrant. And what did we say about the sine of 45 degrees? What did we say earlier on? Sine 45. What do we get for sine 45? We did say that sine 45 is 1 all over root 2, which is the same as root 2 all over 2. So this is the answer for this problem. Thank you for watching. Bye-bye.